Hi guys, this is lesson 7 of our topic on chemical bonding and structure, and we're looking at Lewis diagrams of ionic compounds. Now what we're going to do in this lesson, we are going to use Lewis diagrams to assist us in determining the formulae of simple binary ionic compounds. Now you might wonder, what do I mean with a binary ionic compound? It's an ionic compound that consists of two types of elements. If we look at the example we have here, we're going to look at how we can use Lewis dot diagrams to represent the formula of potassium oxide. Okay, now what we're going to do, we're first going to start with the Lewis dot diagram equation for the formation of the cation, the positive ion. So the metal ion, we will be considering that one first. So this would be the metal ion, okay? So let's just correct that spelling over there. It's not a metal lion, it's a metal ion. So let's just correct that. So this is the metal ion. Okay, so potassium has got one valence electron, and when it forms an ion, it forms an ion with a charge of +1, or 1 plus actually. So we just indicate it with a plus by giving away an electron. That electron can then be accepted by the anion, the non-metal. So when we write the equation for the formation of the non-metal ion, or the anion, this would always be the non-metal. Okay, now potassium oxide means we have potassium and we've got oxygen. Now oxygen is in group 16, so it has 6 valence electrons. If it forms an oxide ion, we know that group 16 will form ions with a charge of 2 minus. So in other words, it needs to accept 2 electrons. So then our oxide ion will be that one over there with 8 electrons around it with a charge of 2 minus. Remember the square brackets. Okay, now if we need 2 electrons for the oxygen atom to become an oxide ion, we must have 2 potassium atoms, which forms 2 potassium ions, releasing 2 electrons. So then our oxide ion, which accepts the 2, or oxygen atom, which accepts the 2 electrons, can become the oxide ion. So in other words, the amount of electrons that's given away by the metal ions must be the amount that the non-metal ions can accept. So there should be a balance. So in other words, our net equation, and what we mean with a net equation, we don't indicate the electrons anymore, because the electrons that was given away here was accepted here, so they basically cancel out. So all that remains is the potassium atoms reacting with becoming potassium ions, the oxygen atom becoming an oxide ion, and now our potassium ions and our oxide ion can bond in an ionic bond. And remember that this is just a representation. It's not, you will never find in nature a situation where you have 2 potassium ions just bonded to 1 oxide ion. They're always in a crystal lattice, which is the repeating pattern of multiples of these. So in other words, the ratio in which they bond, the simplest ratio that we have here is 2 potassium ions for every oxide ion. So in other words, our formula that we will write down is K2O. Now I want to do another example with you guys so that you can just recap on the process we are following when we draw this. So if we go down to the questions you have, I'm going to do number 4, where we have aluminium and nitrogen. So remember, our first step is to write down the equation for the formation of the cation, which is in this case the aluminium ion. So aluminium is in group 3, therefore it has 3 valence electrons. It will become aluminium 3 plus by giving away 3 electrons. Okay, nitrogen is in group 15, therefore it has 5 valence electrons. This is now the formation of the anion. It accepts 3 electrons to become a nitride ion with 8 electrons around it and a charge of 3 minus. Now remember here we've got equal amounts of electrons, so they cancel out. The ones that the aluminium atom is giving away is accepted by the nitrogen atom. So our net equation then is aluminium and nitrogen atoms bonding, but it's not the atoms. I made a mistake here. Hey, yes, you should be awake. Okay, remember this is ionic bonding, so I need to write the ions in the final step. So it is the aluminium ion plus the nitride ion which bonds, and because it's 3 minus and 3 plus, they bond in a 1-to-1 ratio. So basically the formula that I will have, and remember this is how I indicate the formation of the ionic bond, because it's the ions that attract one another with an electrostatic force, different charges. So my formula therefore is AlN. Okay, let's do a final example. So magnesium and phosphorus. Magnesium is in group 2. It's our metal, so it will form the cation. So it has 2 valence electrons. It becomes magnesium 2 plus by giving away those 2 electrons. Then phosphorus is in group 15, so it has 5 valence electrons. It will need to accept 3 electrons to form our phosphide ion. So there's our phosphide ion. Now remember guys what I said, you have to have equal amounts of electrons. Now 2 and 3, if you multiply the 2 with one another, it's 6. So we need 6 electrons, so we need 3 magnesium atoms forming 3 magnesium ions. So in other words, it's 3 times 2, so this becomes 6 electrons. And then we need 2 phosphorus atoms, which will accept 6 electrons to form 2 phosphide ions. So our net equation then is our 3 magnesium ions plus our 2 phosphide ions okay, which forms our magnesium phosphide. Now, there's various ways in which you could write this. You could write it as such, okay, where you indicate that you've got 3-to-2 bonding of the magnesium ions to the phosphide ions. You could also, if you wanted to, write both of them like this. So you will draw your Lewis diagram for your 2 phosphide ions. And you will have magnesium 2 plus, magnesium 2 plus, and magnesium 2 plus. Okay, so those are the ways in which you could represent your answers. So it's either that one or that one, meaning your formula will be Mg3 as a subscript indicating it's magnesium 3 magnesium atoms that you need, or ions actually, and then 2 phosphide ions that you need. So that would be your answer for your formula. Okay, so I hope you enjoyed this lesson, guys, and that you will now attempt these questions on your own and succeed.